Yes, sir.
Okay. Um, the last class we have seen, okay, what is a SR latch? Okay, the latch is, what is the meaning of latch in the sense? It is one of the memory element. Okay, it is a memory element which store one bit of information. Memory element which store one bit information. Okay, so we have seen what are the different ways we can implement SR latch. Okay, we can implement SR latch in two ways. One is SR latch implementation, using NOR gate. Another one is SR latch implementation using NAND gate. Okay, using NAND gate. And then we have seen what is the truth table for SR latch with implementation of NOR gate. Q bar. Okay, so what is the truth table? Okay, the input is 0 1 0 0. Suppose next input is 0 0, sorry, 1 0. Next is 0 0. Last combination is 1. So we have seen the output. Okay, so if we consider SR latch implementation using NOR gate, so what is the input for S? It's reflected to Q. Okay, what is the meaning is the SR latch is associated with the two output. One is called as a Q, another one is a Q bar, and then Q and Q bar. It's a complement with each other. It is a complement with each other. Okay. Okay, suppose what is the meaning of complement with each other in the sense? Suppose the q value equal to 1 in the sense, definitely the q bar value equal to 0. Suppose the q value equal to 0 means the q bar value equal to 1. Such a way that the output should be appear. That's why we call it as q and q bar, we call it as complement with each other. Okay. So what is the truth table for SR latch implementation using NOR gate? Okay. 0 1 0 1 1 0 1 0 1 1. Okay. Sir, how I should remember in the sense? If we consider SR latch implementation using NOR gate, what happened? So what is the input value of S? It should be replicated in the output. Okay, the Q S value equal to 0, the Q value equal to 0, S value equal to 1, the Q value equal to 1. Okay, so that's why that latch, the last input combination, we call it as a forbidden state. So what is the meaning of forbidden state in the sense? You should not encourage like that input combination for SR latch implementation. That is called as a forbidden state. That input combination, we call it as a forbidden state. Okay, the entire latch otherwise called as a SR latch. Whereas in the SR latch implementation using NAND gate, we call it as S bar or bar latch. So why it is called as a S bar or bar latch in the sense? If we consider if we go through the truth table of SR latch implementation using NAND gate, okay, I'm taking same input combination 0 1 1 1 1 0, again 1 1 0 0. Okay, how the output should be appear in the sense? Okay, how the output should be appear in the sense? Okay, it is opposite to it is a just opposite to SR latch. For a way I am saying that in the sense, for example, if they consider this input combination S value equal to 0, what happened? The Q value equal to 1. Whereas you take next combination. Okay, here S value equal to 1, whereas the output value equal to 0. Okay, it is a just opposite to SR latch. That's why it's called as a S bar or bar latch. Okay. Um, so why I go through it before beginning of the session in the sense, it's very difficult to understand. That's why I'm going to go through it. Okay. So next thing is the SR latch. Okay, we are going to implement the SR latch implementation using control input. Okay, I'm going to implement the SR latch. You so okay, I'm going to implement SR latch using NOR gate with control input. With control input. So previously we how the inputs are SR latch should be appear in the sense it should be appear without the control input. So I will tell you what is the necessity of that control input. Suppose you are giving the suppose the movement you are giving suppose the movement input change in the movement the input change. Okay, definitely the output also change. Okay, when the movement the input change, definitely output also change. Suppose if you using the control input, what happen? Even the input change, even the input change, the output should not be changed. The output should not be changed. Okay, so even now I what I'm going to do, I'm going to change the input. Even though I'm going to change the input, it should not change the output. How we are going to achieve in the sense make use of the control signal. Okay, it can be achieved. It can be achieved using control signal. Okay, using the control signal. Okay. Okay, already you know that here how what is the specification for SR latch using NOR gate with the control input in the sense. Okay, it should be appear like that. So before that, what happened? Such a way that what happened? They are going to provide a control input. The control input, otherwise called as the enable input. Okay, this is the input for the NOR gate. Okay, this is the input for the NOR gate. Okay, NOR gate. This is the input for NOR gate. Okay, this is the input for NOR gate. Okay, this is called as a Q. This is called as a Q bar. So this S and R. Okay, this is and okay, such a way that what happened, they are going to provide input for this SR latch. Okay, so now what I'm going to do, I'm going to take the different input combination. Based on that, I'm going to list out what is the functionality of the SR latch using NOR with the control input. Okay, okay. This is called as a Q or Q, Q and then Q bar. Okay, so otherwise they called us the next stage output, next stage output. Suppose, for example, the control input is 0. Suppose I'm a user, so I'm not providing any control input to this circuit. What happened? So whatever the previous stage, suppose whatever the input combination, XX in the sense, whatever the input combination, so what happened? So what is the previous stage input? It can be retained. That's why I'm going to specify it as no change. Okay. So once again, I'm going to tell that. Suppose I'm not providing any control input for that circuit. What is the meaning of XX in the sense? Whatever it input combination, okay. So what is the output of that current stage in the sense? So what is the previous stage output? Okay, that thing retained in the current stage. That's why I represent it as a no change. Suppose I am going to provide input control signal is a 1. Okay. Okay. The input is 0 0 combination. Okay. Okay. Now we are going to check that output. For example, already we have seen the whenever the control signal output, whenever the control signal the sequential circuit generate the output, what happens? So it will take current input, it will take the current input as well as the previous stage output. So where do you save the previous stage output? It is available in the memory element. Am I correct? Okay. So the Q and then Q bar we call it as a previous stage input. Previous stage output. Okay. Now only I'm going to initiate the circuit. Now only what happened, I'm going to initiate the circuit. I'm going to consider, okay, the Q value equal to 0. The initial values which is available in the memory equal to 0. So now what happens, you are going to give the input for that circuit. What happens, sir? The enable bit is 1, here 0, here 0. Okay, so what is the truth table of AND gate? What is the truth table of AND gate? A, B, F. If both the inputs are 1, then only what happens? Output equal to 1. The rest of the cases, what happens? The output equal to 0. Okay, here 1 and 0. What happens, sir? This is a 0. Here 1 and 0. This is a 0. Okay, okay. So next, okay. So one of the input is a 0. Okay, and then another here 0. Okay, so in order to find out the functionality, what happened? You needed one more output. So already we have seen the truth table of we have seen SR truth table. Okay, what is the functionality of NOR? If any one of the input is if any one of the input is 1 in the sense, definitely what happened, it's going to generate the output equal to 0. But here what happened, both the inputs are 0. So that cases what you're going to do, you take the previous stage input. So what happens? 0, 0, 0, 0, 0, 0 in the sense, what is the output of NOR gate? 1. 1. Okay, this is the input for here. Okay, what is the 0, 1? What is the output value? 0. Okay, so what do you understand in the sense? Suppose I am going to provide input as 0, 0 in the sense, okay, it will retain the previous stage. So why I am saying that the previous stage in the sense, initially before starting that circuit, what happened? I consider the previous stage output equal to 0. Same output I get it the current stage also. That's why I'm going to declare that, okay, it will retain the previous stage output that can be denoted as no change. Okay, so it should be behave as the control input with SR latch implementation OR gate. It's acting as its behavior is similar to SR latch. Okay, so already we have seen the behavior of SR latch. What is the behavior? Suppose my control input is 1. My input combination is a 0, 0, 1. Okay, 0, 1 in the sense, what is the behavior of SR latch? The input combination is a 0, 1. If S equal to 0 in the sense, what happened? The Q value equal to 0 and then Q bar value equal to 1. Okay, already I said the Q otherwise called as a set, the Q bar otherwise called as a reset. In your textbook, what happened? Then here now the Q bar value equal to 1. In the textbook, what happened? They given as reset state for the same meaning. Q bar value equal to 1. That's why I can represent it as reset state for the same meaning. Okay, here the Q value equal to 0, then Q bar value equal to 1. That can be denoted as reset state. Okay, reset stage. Okay, next what is the next input combination? 1, 0. So 1, 0, 1, 0 combination, what is the behavior of SR latch? Okay, whenever the S value equal to 1, the Q value equal to 1, Q bar value equal to 0. Okay, so this is otherwise called as a set stage. Okay, the next input combination is a 1, 1. That state we call it as forbidden state. That state we call it as a forbidden state. Okay, there is a behavior of, okay, SR latch using NOR with the control input. Okay, do you have any queries? Do you have any queries?
No, sir.
Okay, that can be represented as like that. How they are represented in the diagrammatic notation in the sense. So one of the input is yes, another input is R. So here enable input is there. Here enable is there. This is called as a R. Okay, this is a Q and then Q bar. Okay, like that they can be denoted. So some cases what happen, they denoted like that. Here bar is there that can be represented as a bubble. Okay, so this is nothing but SR latch using NOR with control input. Okay, behind the queries. Okay, I hope that all of you understood. That's why I forward to next one. The next latch is called as a D latch. The next latch we call it as D latch. The next latch we call it as D latch. Okay, D latch. The D latch, otherwise called as a data latch, otherwise called as a transparent latch. Okay, the what is the meaning of D latch in this sense? Data latch or otherwise called as a transparent latch. Transparent latch. So why it is called as a, I will tell you later why it is called as a transparent latch. Okay, this is a circuit diagram for okay, D latch. It's simply connected with a NAND gate, a D. Okay, it is a complement input for the opposite direction. Okay, one of the input is enable. Okay, this is a NAND gate. Here NAND gate is there. Here NAND gate is there. Okay, this is called as a Q. This is called as a Q bar. Okay, the output of this NAND gate is an input for next NAND gate. Okay, here feedback. This is a feedback input. Okay, this is a circuit diagram for D latch. This is a NAND gate. This is a NAND gate. Okay. So this is a circuit diagram for D latch. So now what happened? We are going to find out the behavior of D latch for different input combination. Here only one input variables are available. D only is there. D is the input. Only one variable. How many number of input combinations are available? Two input combinations are there. Two input combination. So what are the two input combination? One is 1, another one is a 0. Okay, two input combination. One is 0, comma 1. Okay, we are going to check that. So enable input. So here this input is acting as a S. This inverter output is acting as a R. Okay, this is acting as a S. This one is acting as a R. Okay, that can be represented as a D, D dash, or S, R to the same meaning. Okay. Okay. So now what happened? We are going to check that what is the output of for each input combination. My enable input is 0. My whatever maybe input combination, my output is it will retain the previous stage output. That's why I'm going to return as no change. Okay, what is the meaning is my enable input is 0. What is the meaning of XX in the sense? My input combination, whatever it may be. Okay, what is the output means? It will retain the previous stage output that can be represented as a no change. Now the enable input is 1. My input combination is a 0. Here what happened? I'm going to provide input is a 0. Here what happens, sir? This is a 1. Here the inverter is there. What is the output? 0. Am I correct? 0. So my input is sorry, my input is 0, here 0, here 1. Okay, my D equal to 0 and D bar equal to 1. So what is the behavior of Okay, already what is the behavior of NAND gate? If any one of the okay, this is a 1. What is the behavior of NAND gate? What is the behavior of NAND gate? If any one of the input combination is a 0, if any one of the input combination is a 0, what happens? Then definitely output equal to 1. Here 1. Here what happens? Here 1 1 is there. So definitely what happens? Here generate the output equal to 0. Here what happens? This is the input for this NAND gate. So what happens? Here one of the input is 0. Here the one of the input is 0, irrespective of another input, what happens? Definitely it will produce output equal to 1. Okay, here 0, definitely irrespective of another input, definitely what happens? It will produce output equal to 1. Okay, this is the input for here. So what is the combination of here 1 1? So what is the output? The q value equal to 0. Okay, so what do you understand in the sense? If the input is 0 in the sense, it's going to produce output as 0 and 1. Suppose my enable input is 1, the user going to provide input as a 1. So what happened? The user given one bit is 1, here 1, the enable bit value equal to 1. Here what happened? Here inverter is there. Okay. Okay, now I am going to check that what is the behavior of D latch. Here one of the input is one of the input combination is a 0. Definitely what happened? The output value equal to output value equal to 1. This is a 1. Here 1 1 is there. What is the output? 0. Okay. What is the output? 0. Okay. What is the output? 0. Okay. Here what happened? Here one of the input is a 0. Definitely what happened? It generates the output equal to 1. Okay. This is the feedback for here. Here 1 1 input combination. What is the output? 0. Okay. Okay, so what do you understand in the sense? Okay, the q value equal to 1 and q bar value equal to 0. So why it is called as a transparent latch in the sense? Suppose the d value equal to 0 in the sense, the q value equal to 0. The q value equal to 0 in the sense, the d value, d value equal to 0 in the sense, q value equal to 0. Suppose the d value equal to 1 in the sense, the q value equal to 1. Okay, suppose I give the input as a 0 in the sense, it's going to produce output as a 0. Suppose I'm going to give the input as a 1 in the sense, it's going to produce output as a 1. That's why it's called as a transparent latch. That's why it's called as a transparent latch. Okay, okay, this is a behavior of D latch with the enabled input. Okay, do you have any queries? So do you have any queries? Hello. Do you have any queries? So next, so what are the drawbacks are available in the latches? So in order to overcome this problem, what happened? We go for next concept, that is called as a flip flop. Okay, first I will list out the problem with the latch. Problem with latch. Okay, I will list out. So what is first I will tell that how your sequential synchronous sequential circuits is working on. The clock is okay. The clock is generated. What is the meaning of clock? Clock means it's a periodic signal. It's a periodic signal. The clock is a generator. The clock is generated using clock generator. Okay. Okay. The synchronous sequential circuit how is operating on in the sense you are going to provide input as one of the input as a clock. That clock what happen is going to control that entire circuit. Okay. What is the meaning of clock in the sense? It's a periodic signal. What is the meaning of periodic signal in the sense? It should be appear like that. Okay, it should be appear like that. How we are going to generate that clock means because of the clock generator. Okay, this level we call it as a 1, this level we call it as a 0, 1. It simultaneously it should be appear like that 1 comma 0. Okay, that is a clock. Okay, this is a clock. Okay, for example, already we have seen that the SR latch, okay, already we have seen that SR latch, okay, the made up of the SR latch made of NAND and NOR gate. Okay, NAND and NOR gate. Okay, if we give if we give input to SR latches, if we give input to SR latch, okay, it going to take certain amount of the time in order to process the data. Okay, that time we call it as a delay. Okay, it take a input to SR latch. What happen? Okay, it takes certain amount of the time, certain amount of the time, certain delay, and then produce output, and then the produce output. It's going to take the particular time. That time we call it as a delay. Okay, it produces the output. So why it going to take certain amount of the time in the sense? First, it's going to read the input from the user. This is the input for the gate, and then it's going to take certain amount of the time in order to produce output. That is that thing we call it as a delay. So okay, for example, I'm going to case one. For example, so I had one SR latch. The SR latch what happened? Every 5 nanosecond, what happened? It's going to generate the output. What is a clock delay? So what is the meaning of clock delay in the sense? First clock is generated. First clock is initially generated. When the next clock is generated in the sense after 5 nanosecond only. Assume that our assumption after 5 nanosecond only, what happened? It's going to generate the next clock. Okay. Okay. If in the sense what happened? For example, so in the sense what happened? Okay, for example, I will show it in diagrammatic way. So it is easy to interpret the concept. For example, this is a SR circuit. Okay, this is a memory. Okay, this is a memory element, and then it's a feedback for the circuit. Okay, it's going to take 5 nanosecond delay in order to generate the output. So the clock delay also what happened? 5 nanosecond. So what is the meaning is every 5 nanosecond what happened? It's going to generate single output. Every 5 nanosecond what happened? It's going to generate a single output, and then it again feedback for that sequential circuit. These cases there is no problem. I'm going to take another case. So okay, next case what happened? Here what happened? Uh, for example, the SR latch delay is 5 nanosecond. The clock delay is 1 nanosecond. The clock delay is 1 nanosecond. So what is the meaning is? So what is the problem of this scenario in the sense? Okay, this is SR latch. Okay, for example, this is entire clock. Every 1 second, what happened? It's going to generate. It's going to what happened? It is a give input for the SR latch. This is a first clock. This is second and third. This is a fourth and fifth clock. Okay, for example, already we have seen that the SR latch is going to produce output as a after 5 nanosecond only. What happened? It's going to produce a single output. After 5 nanosecond only, what happened? It's going to generate the single output. Here, what is the problem is, here, for example, here clock they given 1 nanosecond. After completing 1 nanosecond, what happened? So it generate the what happened? It generate the output because next clock cycle which is available in the queue. So again, after 1 nanosecond, what happened? Another clock cycle is there. What happened? Again, what happened? It's going to generate another output. Again, the third nanosecond, what happened? One more clock cycles are available. Okay, so like that, it's going to generate 5 different output. Okay, okay. So what I'm trying to say that in the single clock interval, what happened? It's going to generate 5 different output. That is a problem. So overcome this problem, what happened? They go for they go for the flip flop. They go for flip flop. Okay. That's why they go for flip flop. Uh, okay. Uh, Again, the clock's signal. operating on in two ways. One is called as a level trigger. The clock otherwise called as a trigger. The level trigger. Another one is called as a edge trigger. Another one is called as a edge trigger. So I will tell you what is a level trigger. A level trigger in the sense, so for example, this is a clock signal. This is a clock signal. So this is a clock signal. Okay. Uh, okay. This is people called as a one clock. This is called as a one clock. One clock. Okay. For example, this is the input for one SR latch. Okay. When in which clock period it going to operate SR latch in the sense uh, this level. This level only what happen? It going to operate the SR latch. Okay. This is called as level. Okay. This is called as a level trigger. Okay. If we consider any latch, if we consider any latch, the latch is operating on level trigger clock. Level trigger. The trigger otherwise is called as a clock. The latch is operating on level trigger, whereas in the flip flop is acting on edge trigger. Okay. So I will tell you which one is called as edge. For example, this is a clock. This is a clock. Okay. Okay. Okay, this one we call it as a edge. This is called as a edge. Okay, what is the meaning that in the sense edge in the sense? For example, this is called as a edge. Okay, for example, here what happened? This is indicate that zero, and the level is increased. This one we are going to denote it as a one. Here up is there. Again, what happened? The clock is go to the down bottom direction. That can be denoted as a zero. Similarly, again the clock is increased. This is a one. This edge we call it as edge trigger. So what is the meaning is whenever the edge trigger is appear, what happen? Your circuit is operating. That type of circuit we call it as a flip flop. Okay. Again, okay. Do you have any queries? What is the edge trigger? This one is called as edge. 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 Again, the edge trigger is divided into two categories. One is called as a positive edge trigger. Another one is called as a negative edge trigger. What is the meaning of positive in the sense? It will operate the circuit from 0 to 1. Okay. So what is the which edge we call it as a 0 to 1? So it will here this edge we call it as a positive edge because it increased from 0 to 1. So this edge we call it as a positive edge. Then what is the negative edge in the sense 1 to 0? Okay, this edge we call it as negative edge. Okay, suppose I am going to say that circuit is operating on positive edge. What is the meaning there? Whenever the clock is increased from 0 to 1, okay, it's going to operate. That is the meaning of positive edge. What is the meaning of negative edge? So the clock signal is reduced from 1 to 0. That edge we call it as a negative edge. Okay. So finally, I'm going to conclude that suppose, okay, suppose the synchronous sequential circuit. Suppose synchronous sequential circuit operate on edge trigger. Operate on edge trigger. We call it as called as flip flop. We call it as flip flop. Okay, that is called it as flip flop. Okay, do we have any queries? What is the level trigger? What is the edge trigger? What is the positive edge trigger? What is the negative edge trigger? Do we have any queries?
No, sir.
Okay. Anybody else? Anybody else?
No, sir.
Okay. So now I'm going to take the attendance. Yeah, why? So the absentee ratio keep on increasing day by day. What happened? The last class only 50 students are present. Today 52 students are only present. What about remaining people? Okay, thank you so much. If you have any queries to be stay on online, otherwise we can wind up the session.